Hello, this is the second video for section 3.2. In the first video we talked about just the process of solving a system using the elimination method. Sometimes when you're solving these systems, whether it's with the elimination method or with the substitution method, sometimes you're just going to come into some weird results, and that's what we have, what we're talking about. So the idea of weird results. If a system is consistent and independent, there's one answer. And so when you're solving, you're just going to get that answer. You're going to solve for X, you're going to solve for Y, and all done. Excuse me. Other situations is it could have a solution, but there could be an infinite many solutions. And so looking at a graph, that's when the two lines are exactly the same. It's easy to see. The other result is inconsistent. That's when there's no solutions. That's when these lines are parallel. And so again, easy to see on a graph, algebraically, that's what we're talking about here. So take a second, copy these things down, and we'll go through some examples and see what we're looking at. Okay, so in this first bullet here, if you get to a point where there are no variables and you have a false statement, what I mean by a false statement, there's no variables, so what you're going to end up doing is eliminating both x's and y's, or whatever the letters are. You're going to end up with 0 equals something else, okay? It doesn't really matter what that number is, but 0 does not equal 7. This is false. Okay. When that happens, no solutions, it is an inconsistent system. Okay, you're just getting a false statement. It's going to be 0 equals and then just some other number where it's a false statement. Okay, that's a weird result. This is what it means. It's an inconsistent system, no solutions. The second bullet says if you get to a point where there are no variables, excuse me, and you have a true statement, the system has an infinite number of solutions. So by a true statement, there's no variables, so you're going to get 0 equal to 0. I suppose it doesn't have to be 0 equals 0. I've never seen it happen, but I suppose it could be. But either way, it's a true statement. So you've eliminated all the zeros, you've eliminated all the variables, and you've eliminated the constants. It's a true statement. 0 equals 0. This is telling you there's an infinite number of solutions, which is the dependent, consistent system. So weird results, this is how you interpret them. All right, so directions say use the elimination method. All right, so looking at this, I'm going to multiply the bottom equation by a -4. That means the top equation stays the same. The bottom equation has become a -16x plus 2 1/4 times 4 is 9y equals a -48. So when I add these equations up, x's go to 0, y's go to 0, equals a -40. We have 0 equals a -40. That's a false statement. All right? So this is the idea. We don't have any variables to solve for. So when we got a false statement, no solutions. And we're done. No solutions. Sometimes the question will ask you to describe the system. Well, in this case, it is inconsistent. Okay, no solutions. So this is a weird result. Here's how we interpret it. Again, wants to use the elimination method. So please hit pause. I want you to try this on your own, see what you come up with. For this problem, I would multiply bottom equation by a -2. So we're going to get top equation staying the same. Bottom equation, -10x. All right, there's a error in this equation. I'm going to change this to be a 12. Okay, I was starting to fall asleep as I was typing this stuff, so I messed up. So if that's a 12, I'm still going to multiply by -2, looking at the x's. I want to get those x's to be equal and opposite. So minus 6y equals a -24. When I add these equations together, 0 for x's, 0 for y's, 0 for the constants, that gives me a 0 equals 0, which is a true statement. And so what that means, again, looking back at the weird results page, when you end up with a true statement, there's nothing to solve for, but it means you have infinite number of solutions, which is the dependent system. All right. Basically what that means is these two lines, they are exactly the same. They're one right on top of another one. So if you think about what that means, you plug in any x value, it's going to satisfy the first equation and it's going to satisfy the second equation because you're always getting a true statement for both equations. All right, so any x value work, which is why you have an infinite number of solutions. All right, that's the idea of the weird results. The same thing can happen when you're dealing with the substitution method. You get true statements, infinite solutions. You get a false statement, 0 equals some other number. That's no solutions, inconsistent system. That's it. See you in class tomorrow.